Go. There, that's much better. So the funny thing, if you look at the heap spring, is sort of usually you fill memory with 12 and 13 byte and stuff like that. For some reason, they had this value, and I speculate that this is actually a typo in the original. By the author of this exploit in the original ActionScript source code, because if you accidentally type /0b/0b/0b instead of //0b/0b and so forth, you end up getting this value instead. So it didn't really have much of an effect on the exploit this time, because the instructions are also somewhat as long as EBX points someplace in memory that's readable, this is effectively a no-op for the sled. So it turns out that the ActionScript bytecode is actually remarkably easy to read and somewhat similar to the input, so to speak. So you can see that all of the variables are stored in a little section by name in the original names. Things like strings and objects are like native types for the VM. So anyway, this particular code right here, you can see it basically assigns that string value to that variable and that string value to that. So in ActionScript, it would be written somewhat like that. Anyway, this is how loops are done. There's usually they usually stick a label opcode, which is it's sort of a special sort of no-op. It's to make the bytecode verifier's life easier when it's trying to figure out if all of the loops will actually point to regular places. Anyway, it basically means that this is the target of the jump in a loop, and so. It's basically taking values A and B, adding them together, and getting the length, and checking to see if it's bigger than that. And if it's not, then it goes back up here and does it again. So it's a while loop. Same sort of deal. If you need to actually stick, raw, bytes into memory, you can use the write byte operator in the byte array. Does a bunch of that. And so on and so on. This is all very, very standard heap spray stuff. The shellcode itself is stuffed into memory with just a bunch of just writing it one byte at a time through like a couple hundred of these little byte operations. Comes out looking like this. All it does is it goes through memory, finds the slightly encrypted PDF from the other section of the PDF file. Decrypts it, dumps out to the disk, and executes it. And the dropper then goes on and downloads all the other bits of the malware and so forth. So there's a lot of, as I was saying, one of the, traditionally, like most malware has not actually been stealthy in the slightest. It doesn't make any attempts to hide itself. It's all, straight plain text IRC or HTTP traffic, and anyone with a packet sniffer can see everything. And everyone's like, everyone asks me like, why don't the malware authors use like SSL? And they don't have to. Strangely, the way the environment is they can get away with using just straight plain text HTTP. But one of the trends that's starting to occur is people are starting to hide their communication up, so it's a little bit less blatantly obvious. One of the ways they've been doing that a lot is stuffing a GIF onto the beginning of executable files, because there's a number of products, I don't know which companies have them, but they're sort of an IDS product that watches for Windows PE files getting a copy of the network, and then raises some alert. And so if you just stick a GIF header or even just a full GIF onto the front of it, then the IDSs say, oh, that's just a GIF, and they ignore it. So sometimes sometimes they're full, complete GIF files. Sometimes they're not. Typically, there was a downloader. Oops, sorry. There's a downloader that sort of formatted the files this way. There'd be a normal-looking GIF or JPEG on it, so you actually just load it up in an image viewer and look at it. But then it'd be 300K long for like a 15 by 15 GIF, and so it's a pretty simple structure. It's the way that the downloader would know where to start extracting the exes from is you get the length of the offset for, sorry, mic's falling off. The length of the GIF is stored at the end of the file. So you read the D word off the end and jump to that offset, and then you get the length of the rest of the file. So you can like sort of add the numbers together and verify that you've got the whole thing. And then you have the length of the first exe, and that just carves that out. You have a D word for the length of the second exe, and it carves it out, and third one, and so forth. To sort of give a concrete example, this site's no longer up. So there's a full GIF here. It looks kind of like that. Anyway, it ends up out there. This was the end of the file, so it has the length of the GIF, which is, you can see, 403 hex. So 2 goes right there. Then this is the length of everything else in the file from there to there. I moved the end up here. Hopefully you're not confused by that. And you can add the numbers together and they'll kind of add up. So this exe is 3,200 bytes in hex long, or in base 16, and you can see is an exe anyway, and second line, so forth. So, and the third one, I put too many examples in this. So, here's the second example. Basically, same thing. You get the length, go there. You get the length of the other stuff. There's an exe. That's how long it is. Anyway, this one actually, strangely, despite saying it's a GIF, isn't. Actually, it's a JPEG. Looks like that. Anyway, so there's a lot of botnet CNCs do everything in plain text, but they're kind of starting to hide it now because people with packet sniffers have been analyzing them. So they're trying to make it slightly more difficult than just looking at it in Wireshark. So this one bot, it sends a request like this. It gets back something that looks like a JPEG, except it isn't actually. It's a little bit mangled. And then the next thing the host does after it gets this JPEG is it goes out and downloads an executable file from this address. And hang on a second. Sorry, the microphone's falling off. Downloads an executable from here, and there's sort of a cause and effect relationship between the two. So whatever this information is must have come in from here. So it's not really a real JPEG if you try and look at it, obviously. And there are like two examples of it. And you see it's mostly the same bytes. I haven't actually